welcomed by our host, Cawrse Associates. To my left here is Craig Cawrse, obviously the principal of the business, and several of his team members are on site on hand as well.
This paving system has an under drainage system, and as Rachel is hiding somewhere here, she can tell you, where'd she go? There she is. That when 1 inch of rain falls, an inch doesn't come out. That's probably the safe way to say it. And it varies, depends on the intensity and so forth, and the absorption into the stone and into the gravel and a little bit of infiltration. Part of that drainage comes right out here and heads right into the swale.
We had a grant to fund innovative stormwater management, and Craig was one of the recipients of the funding that we had from the US EPA. And part of that is that we monitor the project for 2 years, and so we work with the US Geological Survey and the US EPA to monitor, and the sewer district and anybody else I could find. The Cuyahoga County Health Department helps out. So that collects runoff from the underdrain system so that we can get an idea of the quality of water moving through the system and the quantity of water moving through the system.
We're no dirtier than what falls on the surface, even though we're running through a parking lot. So there is some filtration taking place with the stone sub-basin. The idea is to slow the water down. There's actually some check dams down in there, made of stone, maybe about this tall. Once again, trying to slow the water down, get a little bit of infiltration. This parking lot is built on fill. That down there is really the existing grade, and even a little bit lower in some cases. This never really dried out fully this summer, as dry as it got, but for whatever reason. The grass mix we used, we got from Hiram. It's a prairie nursery out there, and it was there's 2 different Freedom Lawns. One's called Freedom Lawn 1, Freedom Lawn 2, and I think we used Freedom Lawn 2, which had just a fescue that'll get so high. We don't mow it. I have our maintenance people just hit the edge here. So it's actually been seeded all around. We threw some wildflower mix in there, about maybe 10% with the seed, the grass seed, just to get a little bit of color, seasonal color. And a lot of the plant material here was bare root. All the plantings in the detention basin were bare root, and they were done in the fall, late fall. And they did pretty good. This thing has really grown up in a very short time, and it makes me a firm believer in you get the right soil mix in these, and plants will take off. None of the property is irrigated. Things have done real well without any irrigation, and I think you'll see that in the rain garden. Even though there is some water, we have sedges up on high mounds, and they do wonderful. I had a little bit of a steep slope here, and you can see this. This is a sock that's filled with soil mix, and I had a seed mix, and actually the whole bank down here, you can't even tell. Everything's gone in. So it was a softscape solution to what's normally a hardscape problem. Normally you might put a rock wall or something like that, but I needed more support on the corner of this parking lot.
How deep is the soil mix?
In here is, let's see, we go about 18 inches, and then we feather it out on the sides. We made sure the soil mix came all the way up, because with the fill dirt here, it's pretty sterile stuff.
How much of the water that falls on this, of the 10 inches, actually finds its way into your system?
All that survives getting through here finds its way into the system.
Depending on the size of rain, it's holding anywhere from 10 to 15%. And some of that gets lost just in the initial evaporation, or just the wetting of the stone.
Yeah. And there's no runoff. I mean, zero runoff. If you notice, I have no drainage structures in here. There's no need to. In the snow, we take a space and we stack. Nothing goes into the bioswale and nothing goes into the rain garden. That's the orders given to the maintenance people. So laid an inch of sand down over everything. Put a geotech fabric that allows water through it. Then we put our stone, and it was just to try and hold this stone in place a little bit better. And then we have perforated drains. Not that many. Some main lines. and it's not like every 10 feet, but maybe every 50 feet. This in the winter, it's not quite as much ice or snow accumulation as the asphalt. We actually have a website with all the monitoring on it, the USGS does, and if you go under Geauga County Cawrse office, you can get some live data.
But the whole idea behind this whole system was to take any rainwater that's coming down, obviously from rain or any runoff areas, get it off the surface into the system. And when we look at the cross section, we work from the top down. We've got the Eco-Opulok paver, and in the void we have an angular number 8 stone. That stone has to be rinsed. We want it to be free of any fines or any dust. Underneath there, then we have our setting bed, which is 2 inches of same ASTM number 8. Again, it has to be angular and rinsed. Underneath that, then we've got a layer of 57 stone, and then 1s and 2s. So the total section here, from the top of the paver to the very bottom, is about 22 inches, give or take. Now the paver is 3 1/8 inch thick. You've got a setting bed, so you've got 5 inches between the paver and the setting bed. Or underneath here, then we have a system of under drains, just perforated plastic pipe. And the concept there is to take any rainwater that's going to get into the system. If we're getting a rain that's too intense, for example, for the soil to take that water and it starts to build, we could pick it up and control it in those outlets and then take them out. To date, I don't think these pipes have seen any water yet. Any water that should be running off the surface should be going into that flume because everything's pitching that way. Now, no one has seen any water come off the surface into that yet under all the rain events we've had. And they're telling us that it's taking about 52 hours for water that hits to get all the way in and out. And the longer the amount of time, the better, obviously. Because what we're doing is we're using the pavement not only to clean the stormwater and cool it, we're also using it to kind of meter the release rate. So that instead of dumping it all into this kind of vegetated area, while it's taking all the other water from all the impervious areas, we can take it and treat it and hold it back. And by the time it gets out 52 hours later, we should have lessened the volume back there, and we can meter it out at that point. But it's still been treated. It's not hot water from the asphalt with sediment. From a maintenance standpoint, all that really needs to be done is during a rain event, just keep an eye on the area. If you see any skim coating of water during a rain event, that means that area is just localized. It's got some localized clogging. Make note of it. When it's dried up, come out here with a push broom, broom that area out, put all the stone back in, and it should open up again. If you have to do a partial or full restoration, that's basically where we bring in a street sweeper, and we don't use the brushes, but we drop the vacuum and tune that vacuum suction and pull out about the top half of an inch of the number 8s out of the pavement. The reason for the ½ inch is that all the long-term studies show that all the suspended solids, organics, inorganics, and whatnot get trapped and they're held in that top ½ inch. So by removing that, we're going to take the stone with all the contaminants that are held in there and get them out of the system. You can take that water or that stone, rinse it, bring it back on site and resweep it, and you go right back up to 100%.
The rain garden you see here is about 20 by 20, about 400 square feet. Average depth about 8 inches. The deepest part of it's about 15 inches right on the other side of the B-bomb. Its sole function is to take all of the rainwater from our roof, which is about 2,700 square feet. It's filled with Cawrse Brothers bioretention mix, which is a loamy sand USDA classification. Has about 20% organic material in it. 1 to 2 inches per hour infiltration rate, and a pH of about 6.5 to 7.5. What you see here is about 24 inches deep of that soil mix. The pipe comes down, gets collected all the downspouts, comes under the pavement here to just on the other side of the B-bomb. And I can kind of pull this stuff aside. You can see what we've done is we've created basically a reverse dry well. The pipe comes in about 18 inches down. The water surcharges up in the river rock and spreads out within the soil. Plant material wise, we try to select a variety of things, leaf, stem color, flowering. This is one of the B-bomb stems, which is actually square. So not too many plants with a square stem.
You got to remember that a rain garden is only wet when it rains. And a rain garden really is a lot like a floodplain, where plants can be totally inundated, underwater, and then for a great period of the year, it's very, very dry. And as Dale said, this area, the water comes up, and there is an overflow pipe that is totally unnecessary. The water wicks into this area. When looking at rain garden plants, when you're working around the edges, you're actually working with a lot of plants that are actually dry. And then as you get further down, you work with plants that will go to moist to wet. So any plant can be a rain garden plant, but it depends on where you're placing it in the rain garden.
The soil, when it's put in place, is literally dumped in place and then moved around with the bucket. There's no compaction. The machinery doesn't run on it. The only compaction was foot traffic when they planted the plants. You want to make sure it stays, in a non-compacted state. You want it nice and fluffy to drain. The area you see here, 400 square feet, versus the roof, which is about 2,700 square feet. The ratio from roof to rain garden, when you have drained medium like this, is 5 to 1. So you have 5 to 1 area coming into the rain garden.